key insights into hormonal regulation of energy balance. The role of insulin in energy storage. Insulin, a hormone produced by the pancreatic beta cells, is central to the anabolic processes in energy balance. It promotes glucose uptake by cells, especially in the liver, muscle, and adipose tissue, facilitating its conversion into glycogen and triglycerides for storage. Insulin also inhibits lipolysis and gluconeogenesis, ensuring that glucose is utilized and stored rather than produced or broken down. Glucagon and its role in energy mobilization. Glucagon is the primary hormone counteracting insulin, secreted by the pancreatic alpha cells in response to low blood glucose levels. It stimulates glycogenolysis and gluconeogenesis in the liver, leading to an increase in blood glucose. This catabolic action ensures that energy stores are mobilized during fasting or periods of increased energy demand. Leptin and long-term energy homeostasis. Leptin is a hormone secreted by adipocytes that signals the status of energy stores to the hypothalamus. High levels of leptin reduce appetite and increase energy expenditure by inhibiting neuropeptide Y, NPY, and agouti-related peptide, AGRP, while stimulating pro-opiomelanocortin, POMC, neurons. Leptin's primary role is in long-term energy balance, correlating directly with fat mass. Ghrelin and the hunger signaling pathway. Ghrelin is a hormone predominantly produced by the stomach, which stimulates hunger through its action on the arcuate nucleus of the hypothalamus. Ghrelin levels increase before meals and decrease after eating, thus promoting food intake. It also stimulates the release of growth hormone, GH, linking it to growth and energy expenditure regulation. The hypothalamic pituitary adrenal, HPA, axis in energy regulation. The HPA axis plays a significant role in energy balance by regulating cortisol secretion, which influences glucose metabolism. Cortisol promotes gluconeogenesis, enhances the mobilization of free fatty acids, and modulates insulin sensitivity. Chronic stress-induced cortisol elevation can lead to hyperglycemia and central obesity, disrupting normal energy homeostasis. Thyroid hormones and metabolic rate. Thyroid hormones, T3 and T4, are critical in regulating basal metabolic rate, BMR. They increase oxygen consumption and heat production by enhancing the activity of the sodium-potassium ATPase pump. An increase in thyroid hormones leads to a higher BMR, promoting energy expenditure, while a deficiency reduces BMR, conserving energy. The role of adiponectin in fat metabolism. Adiponectin is an adipocyte-derived hormone that enhances insulin sensitivity and promotes fatty acid oxidation. It acts on the liver and muscles to increase AMP-activated protein kinase, AMPK, activity, promoting energy utilization and reducing glucose production. Low adiponectin levels are associated with obesity, type 2 diabetes, and cardiovascular disease. Incretins in postprandial energy regulation. Incretins, such as glucagon-like peptide 1, GLP-1, and glucose-dependent insulinotropic polypeptide, GIP, are gut-derived hormones that enhance insulin secretion in response to oral glucose. They promote glucose-dependent insulin release and inhibit glucagon secretion, optimizing energy storage after meals. Incretins also slow gastric emptying and reduce appetite, playing a role in postprandial glucose homeostasis. Neuropeptides and central control of appetite. Neuropeptide Y, NPY, agouti-related peptide, AGRP, pro-opiomelanocortin, POMC, and cocaine and amphetamine-regulated transcript, CART, are key hypothalamic neuropeptides involved in energy balance. NPY and AGRP stimulate hunger and decrease energy expenditure, while POMC and CART have opposite effects. These neuropeptides are regulated by peripheral hormones like leptin and ghrelin, integrating signals for energy intake and expenditure. Obesity, a disorder of energy imbalance. Obesity is characterized by excessive fat accumulation resulting from an imbalance between energy intake and expenditure. Leptin resistance, chronic hyperinsulinemia, and dysregulation of the hypothalamic appetite centers are critical in the pathophysiology of obesity. This condition is associated with insulin resistance, type 2 diabetes, hypertension, and cardiovascular disease, reflecting the profound impact of disrupted hormonal control on energy balance.